to Inspirage Unscripted for Oil and Gas. This video series is one of 3 parts on trends and challenges in the oil and gas industry. I'm Darren Merching, Strategic Client Partner at Inspirage, where we're focused on helping customers in oil and gas and energy digitally enable the integrated enterprise. Our guest speaker today is Jon Krome. Jon is Executive Director for Oil and Gas Transformation and Strategy at Oracle. Jon describes himself as the guy responsible for translating the industry processes into technology and technology into the industry for over 30 years. So welcome, Jon. Thanks for joining us today. So, Jon, a lot of the things that we talk about today when it comes to challenges in oil and gas, there's different points of this, and I want to go over about 4 different ones today so that you can really give you an opportunity to show your expertise as well as educate our viewers here. So, Jon, talk to me a little bit about how will the rise in the interest in carbon affect oil and gas companies?
Yeah, and that's a great and timely question, particularly because the meeting in Glasgow with COP26 really drew another line in the sand, so to speak, around global climate change. And carbon's going to creep into the discussions in oil and gas companies in a couple different ways. The first is on what's called their own Scope 1 and Scope 2 emissions. So for people that operate anything that's fueled by a hydrocarbon, and this is generally natural gas, compressors, and other pieces of equipment, there's going to be a drive to electrify. Carbon will become a new measure of interest, much like oil and gas production or water production. Carbon production will be one, and the way to attack that is really through electrification. But it's got to be wisely done, because electrification that isn't powered by some form of renewable or lower carbon energy source really just is carbon shifting. And you're shifting the carbon output from the piece of machinery itself to the electricity provider. So it's a 2-pronged approach: electrify and ensure that that new energy source comes from a low carbon, such as renewable. Secondarily, it's going to put pressure on oil and gas producers and the entire ecosystem, including midstream and downstream, as hydrocarbon demand eventually starts to fall because of either regulation or technology making it cheaper or more convenient. There will come a point when electrical vehicles will dominate the roads. And just about every company that is involved in transportation, whether it's marine vessels or it's long-haul trucking or it's rail, is looking for an alternative to today's hydrocarbon. And that means production is going to go down. And there'll be a period of time just before the last gas, the prices rise. But then at some point, and it might be 20 years, it might be 30 years, hydrocarbons really will be for stranded power production, and they'll be for products. So what's the implication to that for companies whose revenue today is based on oil and gas sales? Diversification is going to have to be essential. And you've seen some of that. Some of the big players, particularly in Europe, are starting to open up entire new businesses based on renewable energy and low carbon supply. Others are attacking it by trying to address their own Scope 1 emissions through carbon capture. Ultimately, the market is going to have the biggest driver here, particularly around electrical vehicles and hydrocarbon for transportation fuel. Companies are going to have to think about diversifying. Pipeline companies are an example, because if there's less demand, the pipelines are no longer at capacity. Pipeline utilization falls. What happens to them? Is there carbon to move and transport? Is there fresh water from one source in the U.S. to another as fresh water becomes scarcer and scarcer? So companies are really going to have to start to think about, what does the revenue stream of the future look like?
So that's interesting, and leads me to another question then. I mean, how does these companies look at these investments going forward? How does the higher oil and gas prices today affect their investments and going in?
I love that question, and I hate that question. And here's why: because high oil prices are an investment incentive for the oil company to keep doing what they're doing. And I've worked for many of them. Higher oil prices make more difficult projects, more demanding projects, that much more appealing. And of course, the planners will have to ascertain, is it a flash in the pan, a spike in the price, or is it here to stay that can be forecasted into the out years? So high prices help oil investments and to a degree can act in the short term at least to siphon off investments in other businesses. Now, at the same time, and here's why I hate it and love this question, high hydrocarbon prices, high gas prices, high oil prices are also incentive for alternative fuel sources. Imagine if oil went to $100 again or $150. Can you imagine $200? All of a sudden, a lot of renewable projects as an alternative start to look very good. So it's got two purposes, right? It's got two unintended consequences. The obvious one, most obvious, is it makes the oil and gas investments look better. But it also fuels the alternative energy sources at the same time.
So, I live in Texas, and a lot of the operations that we have here are really around shale. So how does that tie into some of the unique challenges that are presented to the shale developers and operators today?
If you've been reading closely, shale has really taken it on the chin with the demand reduction during the outbreak. And whether it's the outbreak or something else, it's always going to be very sensitive because shale is intended to be one of those types of projects that can be turned on and off more quickly than, say, a large deep water development or getting into a new country altogether. Now, that requires a bit of inventory and drilled and uncompleted wells or DUCs, and you can consider that a waste of capital as it's work in process or work in progress. But the intention is always that you can turn it off and on depending on price. That's the unintended consequence of how we develop shale. But shale also has got a lot of difficult challenges. Number one, it requires a lot of wells, so its land use is not great, although you can do pad drilling. It produces a lot of water and requires a lot of water, so water management all of a sudden becomes a much bigger issue in local communities that might have fresh water limitations or disposal limitations. And then there's the carbon. And this is where you have to think about scope 1 and scope 2 emissions because to a degree, the way we've chosen to develop shale requires an ample amount of flaring and a difficult to measure amount of venting. Now, those have technical solutions. Those have engineering solutions, but they're going to come at a price. So carbon is going to have to be better factored into development costs, and it's going to raise it. Not a lot, but it is going to raise it. Water is a problem looming on the horizon. We don't talk about it as much, but particularly in communities that don't have an endless supply of fresh water, fracturing thousands of wells a year does take a bite out of the local reservoir. So shale operators who used to be just the big folks, and they're now a lot of the little folks, are going to have to be much more sensitive to the ESG stuff, just like the big ones had been.
As I think through all those things, we start to talk about gathering the data because how we're going to know if we're doing better with a lot of these things is going to be measurement. And so now that comes into the point of data lakes, gathering information about it, and it drives us directly over into the Internet of Things because that's how we're going to gather that data. Is that a friend or a foe to oil and gas?
Interesting way you phrase that. And I think it's a little bit of both, and here's why. So IoT has come to mean, in its most general form, using the industrial internet to collect and manage, analyze, and act on data. And that sounds fantastic, right? I mean, I'm doing everything online these days. I buy 3 things a day on Amazon. I can attest to that because the truck shows up outside my house every day. But if you take that into an industrial context, it does get just a little more complicated. So think about these 3 factors for the rest of my answer. Think about cybersecurity. Think about data reliability, and think about latency, the duration it takes to move information from point A to point B. Now, if we're talking about the IoT aspect, that's at the device level, at the sensors on pieces of equipment and things like that, that proposes a risk. And if you think about all the safety critical processes within oil and gas, whether it's in a refinery or for high pressure shutoff valves or HIPS valves offshore and things like that, there is no latency or reliability compromised in the design of those things. It's all hardwired. It's all locally controlled with RTUs and PLCs. So opening up the devices to the internet has a risk. I think over time we'll figure that out. 5G will get more confidence in. We'll figure out the cybersecurity without exception. But today it proposes a risk to owners and operators of safety critical processes and pieces of equipment. Now, if we're talking about the internet doing things like analyzing the data, perhaps off a historian, and there's no executive action required on the analysis, and I call this the difference between short cycle AI or little AI at the edge, built into the machines or built into the edge devices, versus big AI, which is looking for longer term trends that don't require action today. I think there's always going to be a good use case for a slipstream off of the historian or other data sources into cloud applications for analysis. The key is you got to be able to kind of insulate that from the devices that do the executive action so it doesn't propose a new source of security opportunity for bad actors. So the keys are, again, security, latency, and reliability in the entire ecosystem we call IoT. Today, companies are starting to have those discussions, maybe experiment a little bit, but I think it's going to be a while until they give up their fiber.
Interesting. And so as we gather that data and we start to talk, you talked about artificial intelligence and being able to gather that, do that analysis. What's the impact of all of this going to be on the workforce going forward in the oil and gas space?
In the end, the workforce is going to have to be more technologically savvy. And today, there's a part of the workforce that will not change at all. When a pump breaks, a mechanic will have to fix that pump. You're not going to AI your way around that. The HAL 9000 isn't going to magically fix that. It is too cost prohibitive and unrealistic for robotics to help us out for another 10 or 20 years in that. So you're going to have a portion of the workforce is going to be exactly the same. Now, that said, there's a portion of the workforce that's going to have to really up their game. Everything's going to get more electronic, digital. Even engineers are going to have to learn how to use AI tools and not just do trendology. So even the basic petroleum engineers that are there to do production surveillance are going to have to be quasi-data scientists. And that's been going on for many years. I mean, most engineers have a decent background in statistics. They know how to do good causation and correlation amongst different variables in production or facilities. But it's going to get bigger, and it's going to be more important. There's always going to be this struggle, I think, between AI and machine learning, which doesn't care about the science. It really just looks at the data and the trends and things like that, the relationships of the data and the variables, versus the actual science, which are things like Darcy's equation and Bernoulli's equation and laminar. There are predictive models based on hardcore science, and those two are going to have to figure out how to get along. And I think that's manifesting itself to a degree in certain skill sets, like petroleum engineers. They went to school for the science, but they're going to have to use AI with the actual data that they see and reconcile the two. There's probably going to be a need for fewer technical people as the machine does more. As we learn how to build good AI models that do good machine learning and things like that, you might not need 10 people on a team. You might need 8 people on a team or 6 people on a team. And it comes at a time when there might not be those team members available anyway, as petroleum-related careers have a lower appeal, shall I say, today than they did, say, 20 or, for you 40 years ago.
Well, Jon, that's the time that we had today, and I appreciate your insight. Are there any final thoughts that you'd like to provide?
is an exciting time, whether you're a mechanic, an electronics tech, you're an IT, OT, or you're an engineer. There are new tools at our disposal to help meet our biggest challenges, and particularly for those in the oil industry, we typically run towards the problem, not away from it. So I encourage everybody in the oil and gas industry to really, look hard at everything at our disposal to give us more longevity and do better public service.
I appreciate that. So, Jon, thank you for your insights and your expertise today. And we look forward to everyone joining us for the next installation of the Inspirage Unscripted for oil and gas. Thank you for your time today. Have a great day.